So in this video, we're going to cover composing functions, or the composition of two functions. So before we do some problems, let's talk about what it means to compose two functions. So we've talked about the algebra of functions, right? You can plus functions, you can minus functions, you can times functions, you can divide functions. But now we're going to create this new symbol that looks like a little O, and it's read as of. So f of g of x. So this of here is the composition. And then when I say of x, that is the input. So two kinds of ofs, but we are we're saying them like in a string. So I would say f of g of x. So the little o is read as an of. Now, how do we define it? Well, we define it by doing f of g of x. So again, I'm saying the same words, and I'm just changing my intonation. So f of g of x. So here, I've got f of g of x. So the first of is a function notation. So that says take the function f and replace all your x's with g of x. So the second of is this guy here, which says put x as the argument for g, or put x into g. So if you can read the little o as of, you get the rule for free. And what happens when you compose two functions is you make a new function. So you're replacing all of your x's with something. So now let's just look at a function which is the result of a composition. So this function is taking the radical of six minus 2x. And I'm purposefully writing it like that because this is the easiest way. Now you see there may be more than one correct answer. That's true here. But if you think about this, this is the radical of 6 minus 2x. So we could take radical as our outside function, and the thing we're plugging into it is 6 minus 2x. So this is the inside, or the thing that you plugged in. And remember, the thing that you plug in is g of x. So here, I would say that my f of x function is square root x, and my g of x function is 6 minus 2x. Now let's check. F of g of x. So f of g of x. So f of 6 minus 2x. And that notation means in the function called f, replace all your x's with 6 minus 2x. So this would make square root or radical. And then I'm replacing all my x's with 6 minus 2x. Hey, I got back to where I started, so my composition is good. Now, another way we could do this is we could say that this part, let me get a different color. This part here is my original x. So my f of x function, my outside function, would be radical 6 minus x, and then my g of x function, the thing I'm plugging in, is 2x. So if I do that, let's check it. F of g of x would be f of g of x, which is f of, now my g of x is 2x. Okay, so f of 2x means in the function called f, replace all your x's with 2x. So I have square root of 6 minus, and then I'm replacing that x with 2x. So that's another way that you could compose two functions to get this resulting function. Now, it turns out that when you compose two functions, the range of the input function has to belong to the domain of the outside function, right? So if we want to do the composition g of f of x, so g of f of x, that's g of f of x. So f of x is happening first. So in f, we're going to start with a 0, and 0 is going to go to, sorry, I can't follow that line. 0 is going to go to 3, and 1's going to go to 9, and 5 is going to go to 1, 6 is going to go to 4, 7 is going to go to 2, and 9 is going to go to 4. Now, then, whatever we get has to go into the g function. So, can I put 1 in the g function? Yes, I can. So, since 1 is allowed in the g function, 5 is allowed in the domain of the composition. So, I'm going to put for my domain 5. Now, let's see. Is 2 allowed as an input for g? Yes. So 2 came from 7, so 7 is part of the domain of the composition. All right, let's look at 3. Is 3 allowed in the domain of g? Yes. So 3 came from 0, so 0 is part of the domain of the composition. Okay, let's see. 4. Is 4 allowed in the domain? No. You see in this domain there's no 4. So 6 can't be used and 9 can't be used, because when you get 4 out of the f function, you cannot plug 4 into the g function. Okay, so now let's look at one last one, 9. Is 9 allowed in g? Yes. So 1 is allowed in the composition. So the only numbers that we can put into f that lead to something that we can also then put into G are 0, 1, 5, and 7. Order doesn't matter in set notation. And then let's just talk about the range. So we know that we can put 1, so 5 goes to 1, and 1 goes to 9. So 9 is part, this is domain, range. So 9 is part of the range. Let's do the next one. So 7 goes to 2, and then 2, so 7 goes to 2, and then 2 goes to 8. So 8 is part of the range. Okay, let's do 3. So 0 goes to 3, and then 3 goes to 1. So 1 is part of the range. Okay, 4 didn't work, so we're not using 6 or whatever's under that other green X, but I'll do yellow. So, oh, sorry, I did yellow. Now I need to go to blue. Sorry about that. So 1 goes to 9, right? 1 goes to 9, and 9 goes to 1. So 1 is part of the domain. And those were the only values we were allowed to use from the domain of F. So those are the only values we get in the range of the composition. So now you can see in the range here, we wrote 1 twice, and that's silly. We wouldn't write something twice in a list, right? If I was calling out roll, I wouldn't call Helen and then call Helen again, right? Okay, so now let's compose two rational functions. So we've looked at composing just two functions in general. Now let's compose two rational functions. There's a trick to doing this one that is not, I don't know, it depends on your algebra skills. So let's find f of g of x. So that means f of g of x, which means f of, now our g of x is 13 over x. And what this means, f of 13 over x, means in the function called f, replace all of your x's with 13 over x. So I'm going to do 13 over x, big divides, and then I'm going to have 13 over x again, and then subtract 1. Now, before we simplify this, let's look at 13 over x, because that's the first thing we're going to do. So, in using 13 over x, we know that x cannot be 0, because if x is 0, then I've got 13 over 0, which is bad. So x can't be 0. So now let's simplify our rational function. So here I've got 3 little baby fractions in my fraction. This guy's technically 1 over 1 if you want to see him as a fraction. So now the LCD for all of those is x. So if I times all 3 of them by x, on top the x cancels with the x on bottom, and I just have 13. And then on bottom, x cancels with x, so I have, again, just 13. And then on this last fraction, nothing cancels, so 1 times x is just x. Now, if you look at this guy, Here, 13 minus x cannot be 0. So that means x cannot be 13. So we've got two restrictions for this function. So here's my function, f of g of x. And now we have to talk about its restrictions. So the restrictions are x cannot be 0. So here's 0. And I'm going to put an open circle. And I'm going to color in everything else. And then my second restriction, x cannot be 13. So here's 13. I'm going to put an open circle. And I'm going to color everything else. So now when you've got more than one restriction on a composition or on a function, more than one restriction on a function in general, you find each little restriction and then you find the intersection. So here, if we intersect these, this is double colored, this is double colored, and this is double colored. So this interval is minus infinity to 0. Union. Middle interval is 0 to 13, union, and then the last interval is 13 to infinity. So this is the domain of the composition f of g of x. So again, when you're looking at composing two functions, whatever function you put in as the argument of another function, so in this case g, whatever function you put in is, you have to look at that guy's domain. Then you do your composition, simplify, and then you have to look at the domain for that.